Each of Musk's companies has very different requirements when it comes to computing. xAI focuses on training large language models and handling massive datasets. Tesla needs real-time processing for autonomous driving, where decisions have to be made instantly based on sensor input. SpaceX operates in environments where reliability and efficiency are critical, especially in space systems where hardware cannot be easily replaced. So Elon Musk is planning a $25 billion project called TERAFAB, focused on building advanced AI chips for his own companies. The idea is simple on the surface. Instead of relying on external suppliers, build a dedicated system to design and produce chips tailored specifically for the needs of xAI, Tesla, and SpaceX. Using the same type of chip for all of these applications is not ideal. Custom chips allow each system to be optimized for its specific workload. This can improve performance while reducing power consumption, which is a key factor in large-scale operations. The scale of the TERAFAB project suggests that this is not just about designing chips, but about creating an entire ecosystem around them. This includes data centers, manufacturing partnerships, software integration, and long-term infrastructure planning. Building chips is only one part of the process. Making them work efficiently across different platforms requires coordination between hardware and software at every level. One of the main reasons behind this move is the increasing demand for computing power in artificial intelligence. Training advanced AI models requires enormous resources. The cost is not only in hardware, but also in energy and time. By designing chips specifically for these tasks, it becomes possible to reduce inefficiencies that exist in general-purpose hardware. For Tesla, this approach is not entirely new. The company has already developed its own full self-driving chips to handle onboard processing in vehicles. These chips are designed to process visual data from cameras and sensors with minimal delay. Extending this idea to larger systems through TERAFAB is a natural step forward. SpaceX also benefits from specialized hardware. In space applications, systems need to operate under strict power and reliability constraints. Custom-designed chips can be optimized for these conditions, improving performance while reducing the risk of failure. For xAI, the focus is different, but equally demanding. Training large AI models involves moving and processing vast amounts of data across clusters of processors. Efficient chip design can reduce the time required for training and improve the overall performance of the system. Another important aspect is supply chain control. The semiconductor industry has faced shortages and delays in recent years. By investing in its own infrastructure, Musk's companies can reduce their dependence on external suppliers and gain more predictability in production. However, building a project like TERAFAB is not simple. The semiconductor industry is one of the most complex in the world. Designing chips, manufacturing them at scale, and keeping up with rapid technological changes requires significant expertise and long-term investment. Even large companies face challenges in this space. In simple terms, TERAFAB represents an effort to take control of one of the most important parts of modern technology. Instead of adapting to available hardware, Musk's companies are aiming to build hardware that fits their exact needs. If the project succeeds, it could reduce costs, improve performance, and give these companies a stronger position in the rapidly evolving AI landscape.